Welcome everybody to the Spotlight stage. My name is Mark Demers, and I get the privilege of introducing some incredible presenters this morning and now this afternoon, and what a fun one we have for you right now. So I know Brian on the main stage asked, like, who are the gamers in the group? Like, we got gamers here? Kids, gamers, right? So I'm joined by some great friends here from SAS that run the business unit for gaming and simulation, and you saw some of that this morning. And I'm going to turn things over to William and to Paul. So, over to you, gentlemen.
Yeah. All right, guys. You excited to see some stuff about digital twins? Yeah, come on. We can get louder than that. Come on. All the people here, they want to know what you're watching. No, this is going to be really cool. This is going to be, I think, a fun, pretty quick overview of what I think is some really break frame next generation tech that SAS is pursuing here. So just a quick heads up, what are we actually going to do? You're going to hear from me for a couple minutes. I'm just going to go over sort of the why of digital twins and why businesses might want to deploy them, sort of high level benefits. And then the majority of the presentation is going to be given by Paul, and we're really going to go into the how, the technical details here. I'm not standing in front of the slides, am I, guys? We're good? Yeah. Sure. All right, let's go into our why here. So I should begin by saying, and hopefully you guys got this messaging from Brian's talk on the main stage, but digital twins are really important strategically to what SAS is trying to drive here. You know, when you look at sort of our areas of innovation with quantum and generative AI, digital twins are right up there as a use case and a tool that we think is going to really change how businesses deal, deploy, and analyze their data. So I should also say, though, that you probably noticed Paul and I's title has games in it. And that's because actually at SAS, we do more than just digital twins. We actually have a whole separate line of business where we work with products for games and games companies. We have technology that allows you to directly inject complex content into games. We also have other series of techs that allows us to actually use internal game events to trigger external messages and portals. And we even have a fully functioning demo of SAS's decisioning technology integrated with, for example, a mock game store. So probably not for this audience, that's not why we're here, but if anyone is interested in learning more about that, definitely grab Paul and I afterwards, because we're also excited to just talk about games and how good or not good we are at Valorant. Anyway, no Valorant players here? Yeah, there we go. Yeah, it's Viper. That's all I'm going to say. All right, so let's talk about digital twins here. And let's really go over what I think at the highest level is probably the coolest and most powerful business value from deploying digital twins. And that's really something that I would call cross-effective insights. Now, you might say, our slide isn't animating here, so you guys are missing an effect here, but bear with me. What do I mean by a cross-effective insight? I mean, think about what Brian and GP and Epic Games showed on the main stage, right? They showed a digital twin that was being used to optimize AGV pathing and routing. And then they showed that same digital twin being used to generate synthetic data to train computer vision models for worker safety, right? That is pretty incredible. I would not a priori think that those two use cases could be solved by the same business tool. But again, because digital twins are so powerful, because they really are an in-depth simulation of the real world, once you make that upfront investment to build a sufficiently advanced twin, you just have tons and tons of related cross-effective cascading use cases, because you effectively have built a real-world laboratory that you can play and experiment with your business in. So, what are the three best reasons to use digital twins? What are use cases that should trigger your business exploring this? So the first is complex interactions, right? Anytime you have a particularly nuanced or multifaceted business process, so again, the manufacturing stuff we showed with GP is a great example of this. Digital twins are really excellent to deploy to find solutions or optimizations for those problems. Because anytime you use a purely algorithmic solution, there's some abstraction that goes on that necessarily hides some of those core details under the hood. So again, anytime you have a really complex interaction, really great opportunity for a digital twin. Another great example is anytime you have a rare or very expensive event. So we talked about this with worker safety a little bit. Obviously, your ideal number of workplace safety violations is 0, right? So in an ideal world, you have none of that data to train computer vision models on. So the synthetic data produced by digital twins, very, very powerful for dealing and working with rare events. And again, I mentioned expensive events too. If you have something that is really difficult or time-consuming to simulate in the real world, digital twin's perfect for that. That's why you see a lot of digital twin deployment already in like the aerospace industries, NASA, satellites, stuff like that. And then the last reason for businesses to look at digital twins, I think, is anytime you need a more intuitive take, a new intuitive interface for working with, understanding, or conceptually interacting with your data. Particularly if you think of the next generation of managers and leaders in companies today, they grew up on video games, right? They grew up playing, hopefully, Super Smash Brothers, because I like that one, but they're very familiar with interacting and dealing with complex environments in these 3D simulated worlds, right? And being able to realize your business and your business processes through that same type of simulation just makes them much easier and more grokkable, I should say, for business use cases. So those are the 3 reasons to investigate digital twins. The last thing I will say is digital twins work for a really wide range of industries. So even though we have focused on the manufacturing use case, because we only have time to really present one use case today, digital twins basically work in any sort of corporate or business environment. So particularly healthcare, travel, shipping, even finance, all of those are great use cases to consider deploying twins. So if you guys are in any of those sectors or others, and this looks exciting or interesting to you, please reach out to us, have conversations, and we're happy to take you through the tech and what we're doing in more detail. But now that's enough of me. Let's hand this over to Paul, who's going to show you the how of how all this works.
Great. Thank you very much, William. And this is advanced here?
It's advanced, yeah.
All right. Well, let's get into the how here. As you guys know, we have a partnership now with Epic Games, which is very exciting. We saw Bill Clifford on the stage earlier. Unreal is definitely the premier engine for building photorealistic assets, right? And it has the best physics as well, right? So when you want to simulate the real world realistically, you want to use this engine. We have access to certain engine features, maybe not everyone does because of this partnership, which is great. We're getting help, for example, with RTSP feeds. It's something we're using the computer vision portion. I'll talk about that in a minute. And there's also things like reality scan. So you saw those AGVs driving around the plant, right? Those were actually captured using a phone camera. You take a whole bunch of pictures all around it, and it allows you to build a point cloud. From that, you make a mesh, and you can make a 3D model. So it's very true to life, and say maybe you don't have an accurate CAD drawing of something you want to put in your facility to make it look realistic. You can capture it using reality scan. So now, with that, we'll show you the demo video again, if you want to roll that real quick. So you guys have seen some of this footage before, but we'd like to call out some other things here. You see a lot of palletizers through this plant, right? So essentially they wrap packaging. They have a few inputs. You have pallets themselves, some plastic to wrap around them, slip sheets in between. Those are all ingests, right? Then you have products going in, and from it, out come wrapped packages. Those get carried around by our AGVs. You can see those here. So we have this whole design interface here where you can add AGVs. You can set any number of parameters on these. You can change their rotational speed, how quickly they can move, how heavy they can lift things, and how high. You can set all these in our interface so we can make this very kind of flexible, extensible solution you could use for a range of different AGVs from different manufacturers, right? We also are building with an open spec, but as you can see, you can move around the nodes, right, and run a new simulation saying, hey, what if we actually had to direct traffic to a different place in our plant? Very simply with this intuitive interface, right? We have this traffic jam problem here that we saw on the main stage earlier, but you might think like, hey, we want to get better throughput in our factory, right? How would you go about achieving that? Well, maybe if we just throw a couple more AGVs in there, it'll happen faster, right? More hands make light the work. Here's the problem though, right? Why don't we actually test that out in a simulation and see what happens? We added some more. AGVs have these hard-coded safety parameters where, as you see, if they get too close to each other, they have to slow down, right? This is going to change the travel time along this graph here of nodes and edges, right? It's effectively a graph of movement paths that they can take through your facility. But when they get close, they slow down, right? So whatever you predicted the travel time was going to be, it can be interfered with by all kinds of unforeseen circumstances, either traffic being too dense, maybe people getting in the way, maybe something falls off of an AGV, right? So you need to adapt in real time and find new optimal solutions for pathing and scheduling for your missions throughout your facility. As you can see here, yes, we have these all backed up. So now we want to run an optimization, say what is the true optimal number of vehicles we need in this fleet to accomplish things, and you can see if you reduce the number of AGVs, you actually get a lower mean mission time. So maybe a little bit counterintuitive, but it makes sense when you think of it like a traffic jam, right? Throughput is not the highest with the most things on there. And I believe this is coming to an end here. This facility, by the way, this is just a demo facility for security reasons, but it has all the same assets as the real plant in Savannah. Those battery backups are not on screen anymore, but I wanted to point out that they look great. This stuff looks exactly like the real thing because we scanned it from reality, right? Thank you very much. So we combined two core modules here. The internal name for the project, this is not official, but is Symmetry because it combines simulation and this mirroring of the real and virtual worlds, right? So they're symmetrical. We are basically validating the analytical solutions to optimization problems in engine, because as I said, there are things that happen in reality that aren't necessarily reflected by an analytical solution, right? This then is coupled with our back end here. So this is where all the optimization takes place in VIA. We can also run these optimizations in ESP if it needs to be on-prem and a little faster for streaming data. And with this whole system, you can manage fleets, simulate fleets, see what happens if you close lanes. So we have this control element here, right? This is a filament UI. If you're familiar with SAS, you may know that's what our new front ends are being built in. Base map editor, you can configure routes, number of vehicles in the fleet, as you saw being adjusted earlier. And then we're working on these sparse space-time networks to optimize the pathing and scheduling through the plant, right? So it's not just about what path you take, it's do you have enough space between things so they don't get backed up. Then, of course, on the front end, we have this beautiful, shiny simulation of the real world that actually reflects physics. So what kind of functionality do you have? Basically what you'd expect you need to manage a fleet. We can save and load configurations, build factories from the ground up with different paths throughout the facility. We can edit factories' physical assets. You can say, hey, I want to see a what-if scenario. What if we wanted to move an ATLS, for example, a truck loading system, from one part of the factory to another? This is a real thing that happens. Sometimes you want to reconfigure your plant, right, for logistical reasons. But you may not really anticipate, like, hey, how much impact will this have on our traffic flow? It's hard to know that unless you actually simulate it realistically, right? So this allows you to check those things before you take all the effort of moving a giant conveyor, right, to a different part of your plant. Obviously, we have a lot of optimization, as you might expect here in this kind of logistical scheduling problem. We can iterate over ranges of meta parameters, as I said, like fleet size and different path sets. And we can also ingest real-time data from any facility as well and render it in engine, right? So it's not just for simulation. It can also be essentially like a 3D dashboard that's very intuitive to look at, think about what's happening in your facility. We built Symmetry from the ground up to use VDA 5050. This is an open standard essentially for data interchange for AGVs, for these kinds of robots. And it uses LIF, yeah. The reason we did this is that this allows our solution to be extensible and vendor agnostic. Right now, there's a lot of proprietary software different vendors have. They want you to buy the machinery from them, buy some robots from them, but they want you to use their software as well. These companies are not experts in optimization like SAS is, right? So this is where having our extensible solution able to be dropped in is really valuable. Well, all right, we're in this dynamic environment, as I mentioned, right? There's a few resources you want to optimally utilize. You can think of like the two sets of resources you have are AGVs themselves and then the routes that are possible to move along. You want to maximally use those in the correct way to get maximum throughput for a certain set of parameters, right? We have to account for things in these optimizations like directed and undirected lanes. Some things are for two-way traffic, right? So you may have to wait for one to go past before you can send another one the opposite direction on the same path. And we need to space things out in time so they don't get backed up. You can also, as William mentioned, look at unplanned events and how they actually impact the analytical output that we got from our optimization solver. We can account for things like lane closures, which happens when there's a spill, or maybe you need to repair the stairs, something like this happens. This happens all the time. So you say, well, what is it actually going to do to the movement of goods through the plant? And you can actually see realistic solutions from our simulation. So with that, I'll cue up the second demo here, CV, computer vision. This is one I'm the most excited about. I've worked on various computer vision things in the past. If you know, one of the challenges to augment your data when you have high class imbalance, which was mentioned before, right? Basically, there's not a lot of footage of people getting injured or doing dangerous things, hopefully. The vast majority of footage is boring. Nothing's happening, right? So you would really like to have better class balance, meaning more footage of sort of unsafe conditions. You don't want people acting these out, because obviously it's not safe for real people. But when you have a simulated environment like this, there's no risk to anyone. You don't have to scrub PII from the footage, which is a very time-consuming human task. You have to go through, get rid of everyone's faces, anything that might identify them. You can do all these different poses, right? There's PPE that you can switch in and out. There's a lot of need to identify automatically from video feeds whether people are wearing their vests, wearing their helmets, right? So you can train models. And as you see as well, for human pose estimation, you saw those points labeled. Generally, for this task, it is human labeled data. Someone goes by every single frame, clicks on every shoulder, every wrist, every ankle, right, to generate the labeled data. With this, we know the ground truth, and you don't have to do that. So there's a number of advantages. You can get different camera angles, lighting conditions, as we said, right, to get a much more robust training set and build a better model. What's the other advantage? As well, as William said, this one product lets you do two very different things. Once you've actually built the simulation that is a photorealistic rendering of your environment, you can use it for these computer vision cases with basically no extra lift. You stream the data directly out of Unreal Engine over a video feed. RTSP is what we generally use. ESP can ingest that and train and score models in stream. Great thing about these ESP models, you can also publish them in a container and deploy them on the edge, meaning stick them in a security camera, and then they can run at very low latency in a facility. And when it comes to safety, obviously, like a few seconds really do matter. You don't want to be waiting for things to go out to the cloud, come back. If anything slows down, maybe you won't get a safety alert fast enough to cause a real problem. So, yes, security, as I said, things are sparse. I'll do a very quick run through this architecture diagram, but as I said, essentially, right, you have a simulated environment, you do all these great things to make better, robust synthetic data, send it on RTSP over to ESP, publish a model, deploy to a device, and run live. And then when you have new things happening live, and you say, hey, we didn't really actually have much training data of this kind of dangerous behavior, you could then build it into your simulation. The feedback loop continues, right? When you see people doing things in the real world you would have never imagined, we can set up those scenarios and create as much data as we want. So that brings me to the end of it. William, I don't know if you wanted to do your matrix slide.
Yeah, I think we're basically at time here. But the bottom line is I have this Morpheus, blue pill quote up here, because the reality is I really do think we are at a moment in time when digital twins are going to become just sort of like visual analytics, right? It's going to be, if you have data, it's going to be an expected way to interact and interface with it. And so I really do think this wave is coming. SAS is leading it, and it's something you need to seriously consider for your organizations. So definitely reach out, have dialogue with us, because SAS is here to help.
And come see our booth over here. You can even see some of the gaming stuff. We brought that too, even though it's not the focus. Yeah.
So with that, thank you guys so much.
Thank you very much.
Thank you, William and Paul. That was unreal, or should I say symmetry. But thank you, guys. And we're going to have a real quick turnaround. And then the last presentation for the spotlight stage you don't want to miss. It's going to be about agentic AI. So it's starting in 10 minutes. So get yourself a glass of water, coffee, and please come back.